All right, let's look at this first row here on this worksheet. And so what we're looking at is a special function. Now the type of special function that we have here, as indicated by those double brackets, is a step function. So this is a step function, and we would expect it to have a general shape of something like this, whether the steps are going up or the steps could be really long going down. So there's lots of varieties here, but we know what it's supposed to look like. So what we're going to rely on mostly is an XY chart. Now if I put some points in here, let's say -1 and 0 and 1, because they're nice numbers. When I do my XY chart, I'm going to have to put them into the greatest integer function, or the step function. So I'm going to have the greatest integer at -1 minus 2. Well, the greatest integer at -1, what that means is if I'm going up the ladder or the x-axis, I'm going up and I get to -1, the greatest integer I've crossed so far is in fact -1. And when that happens to be an integer, we're going to end up with a solid endpoint. Okay? So the ordered pair point, -1, -3 is a solid endpoint. Okay, so it's going to be right there. If I go to the next point, 0, the greatest integer at 0 is, again, I'm going up the ladder and I want to get to 0. The greatest integer I've crossed so far is 0. So I have 0 minus 2, which is a -2. And that is, again, a solid endpoint. Now I can go to the 1. I'm heading up and I get all the way up to the 1. The greatest integer we've passed so far is a +1. So I have 1 minus 2, which is a -1, as my answer. So we're just using an XY chart along the way. So this right now looks like a line. It does not look at all like a step function. So what we have to do is once we have all these endpoints, and it might happen naturally, but sometimes we have to help it out, we're going to pick points in between our endpoints. So maybe I want to pick, say, 0.7 is between 0 and 1. So I need to figure out the greatest integer at 0.7. So as I'm going up, I get to 0.7. Okay. The greatest integer I've crossed so far is the x-axis. It is the 0. So this is like a 0 minus 2, which is a -2. So at 0.7, I am still at -2. Okay. Let's try a negative also, because those can be interesting. Let's say I have a negative 1/2. If I am at -1/2, then as I go up, -1/2, traveling up, the greatest integer I've crossed at -1/2 is actually the -1, because 0 is above it. I haven't passed it yet. So I'd have -1 minus 2 is a -3. So the reason that we do this is so I have an idea which direction our steps are going to go. Are our steps going this way, or is each step going this way? Okay, and it has to deal with a negative. So according to this, it looks like our solid red endpoints, and we're going to go to the right. So my final answer is going to look like this. And again, the reason we have those circles is because we can't have a solid dot and 2 solid points, or else it would not be a function. And we could continue this pattern accordingly. That is your step functions. Domain for this particular item, as it could keep going, I could have every single real number, every x, be part of the domain. But my range values are a little bit different. They are only the integers on this problem. Okay, it could be different. But for this one, that's what we're looking at.